previously we did these things called taking the average rate of change of curves. So if we take a look at this diagram, I just drew a gray curve. Didn't necessarily have a specific equation in mind, but the point is, so let's say I bound the curve. So I bound the curve between x equals b and x equals a. So in this region. So let's say I want to figure out the average rate of change between x equals a and x equals b. So we've got an a comma f of a and a b comma f of b. Well, I'm just going to ignore this curvy part of the graph and say, well, what's the average rate of change? So if we want to figure out the average rate of change, we just use the slope formula, the y2 minus y1 over x2 minus x1, and we take f of b minus f of a. Sorry, I did it backwards. Let me just do it rightly. So this is x1, y1. This is x2, y2. So the slope would go y2 minus y1 over x2 minus x1. And that would be f of b minus f of a over b minus a. So that is what's called finding the secant line. The secant line is the line that calculates the average rate of change of 2 points on a curve. So Isaac Newton says, well, hey, that's not good enough. In fact, I don't want the average rate of change. I want to figure out the instantaneous rate of change. There's so much to be said about this curve that, like, the average rate of change it's useful, yeah, but it doesn't take into consideration the changes of speed, the changes of change. Like if you're running the mile, you're not going the same speed the entire time. If you're driving in a car, you're not going the same speed the entire duration of the car ride. So, just because you get from point A to point B in 10 minutes, that doesn't mean that you went the same speed for 10 minutes. It means you probably sped up, slowed down, hit the brakes, got up to a good speed again. Right up here, it's increasing and then it decreases to get down to x equals b. Isaac Newton cared about the changes between x equals a and x equals b in more than just a way of calculating the average rate of change. So with that being said, if we want to calculate slope, previously the rules of algebra said that we can only calculate the slope of a line. We can only calculate the slope of 2 points if it's a line. And we can only calculate the slope of 2 points if the 2 points are separate. So for instance, let me get my graph really quick. There it is. So if I take a look at my y equals x squared graph, well, I can't just say that the average rate of change between x equals -2 and x equals 3 is the slope of the entire duration of the graph. I can't calculate the slope between x equals -4 and x equals +2. It speaks for the entire duration of the graph. And you know what? Isaac Newton said, you know what? Let's say I want to figure out the slope of x equals 3. Well, who's to say that I can't pick x equals 3 and x equals 3.1, or x equals 3 and 3.01, or x equals 3 and 3.001. So what you would end up doing is taking, so this is a curve, right? Y equals x squared is a curve. Well, Isaac Newton said, if I zoom in close enough, it looks like a line. Sorry, it's out of focus, but if I zoom in close enough at any given point, it looks linear. So, to your logic. And if I calculate the slope between x equals 3 and x equals 3.1, those are two separate points. X equals 3 and 3.01, those are two separate points. X equals 3 and 3.001, those are two separate points. X equals 3 and x equals 3.001, whatever that is. I didn't calculate that in the calculator. You know what? Those are two separate points. Better yet, you know what? Forget it. I bet you I could figure out a way to calculate the slope at 1 point. So that's what Isaac Newton's lifelong goal was. I mean, among other things, he talked about physics. He talked about splitting colors in a prism. Yeah, the man was a genius. Um, there's my paper. So, do you guys get the idea that Isaac Newton turned the world of algebra upside down by saying, I can take the slope at one point, and it's called the derivative. So, what is a derivative? Well, the formal definition of the derivative is f prime of x is defined as the limit as h approaches 0 of f of x plus h minus f of x over h. I'm not going to stress too much about the formal definition. If time permitting and you guys make a special request to do formal definition of derivative problems, I might do it, but I'd rather you understand what it is. It is basically the slope formula at one point. But if you want to know the informal definitions, well, these are the two most popular. The derivative is the instantaneous slope of a particular point. So it's the velocity at one point. How is your speed during the mile run, in PE class? How is your speed at 30 seconds compared to 4 minutes? How is your speed, from the beginning to the middle to the end? It's going to be completely different. And finally, the other popular definition, which we haven't talked about yet, is in most calculus classes, they say the derivative is the slope of the tangent line. And I've eased you into this because, well, wait a minute. What is a tangent line? Remember that a secant line, sorry, let me get that paper really quick. A secant line is the average rate of change between x equals a and x equals b. Well, what if I shrunk the boundary of x equals a and x equals b, and I just moved the boundary closer and closer and closer? So as x equals b gets x equals a and x equals b gets closer and closer and closer, the secant line starts to become one point. So the tangent line is the slope at x equals a, where it's basically x equals a and x equals a plus 0.00000001. So it's the slope at one point. Sorry, I was stumbling. But the point is the tangent line touches a particular point on a curve in the direction of where it's going. In other words, it is the slope at one point in the direction of where it's going at that time. But just to apply this to real life, what does going on a tangent mean? So some people might say it means rambling. It just means talking on and on and on. But really, what a tangent is it takes one point of the talking in that direction. So if somebody is saying, talking about ice cream, and they say like, oh yeah, I had chocolate ice cream, I had vanilla ice cream, and I just think, ice cream is very delicious on a hot day. Like if you're going to the theme park and you get some Dippin' Dots, and then somebody else chimes in and says, oh, Dippin' Dots are amazing. You know what place has Dippin' Dots? The Chase Center. Oh, the Chase Center is home of the Golden State Warriors. Oh man, Stephen Curry is really great. No, so even though it seems like it's a topic that's out of nowhere, technically they did touch the conversation. We were talking about ice cream, and that person associates ice cream with Dippin' Dots at the Warriors game. So anyway, so the tangent means that you take one aspect of that conversation and go in that direction. Wait a minute, we're talking about ice cream. Why are we talking about anyway? Speaking of tangents. So if I just took that exact same curve, and let's say I calculate x equals a. So this is x equals a, y equals f of a. This is the point that I care about. Well, that red line touches the curve. Let me get my pen. Sorry about that, or pencil. So if I want to touch x equals a in the direction of where it's going, can we agree that it's kind of a positive slope? This one accurately depicts the slope at that particular point. So that's what's called a tangent line. Just to give you guys time to breathe. And by you guys time to breathe, I mean me, because I've been talking a lot. So let's do some problems. So let me get my cover. So how do you calculate the tangent line at x equals a? Well, story time. So in the fall of 2009, I was trying to get my hours in to get my teaching credential. I graduated high school in 2006, so I went to my previous high school 3 years later to observe 45 hours of a classroom, of a math classroom. So I picked three of my old high school math teachers and observed them teaching. So I observed my pre-calc teacher from high school at the age of 21. So I was 21 years old, observing my old teacher. And he was in his calculus class talking about how to find the tangent line of any point on a curve. And the class was clearly lost. They were just like, they were just squinting and scratching their heads and going, And so my teacher was like, you need to evaluate f of a, and then you need to evaluate f prime of a, and then you put it in the formula y minus f of a equals f prime of a times x minus a. And so I had to be quiet. I had to sit in the back and with my clipboard and go, what did he do right? What could he improve upon? So I'm like a fly in the room. I can't say anything, but I knew my teacher from my teacher was a really nice guy. So I raised my hand and I said, do you mind if I actually give this a shot? And previous to that, I was just walked around and helped out, independently when they were doing quiet work. So for me to raise my hand and say, hey, do you mind if I, help out a little bit? And like the entire class just like started clapping and going, yeah, man, let's go. Yeah. So this was my first time teaching a class of 20 plus people. I was a tutor before, but this was my first time in front of a class after high school teaching. And so I said, do you guys remember Algebra 1 and Algebra 2, where you had to find the equation of the line and you had a point and a slope, or 2 points? Well, it's basically the same thing. Remember that f of a is the y-coordinate of that point x equals a. So step 1 is to find the point by plugging in x equals a to calculate the y-coordinate of the a. So evaluate f prime of a. Well, remember what a derivative is. F prime of a means that you are finding the slope at x equals a. And this formula that my teacher gave, it's like, hey guys, remember algebra? You go into point-slope form. Once you have the point and once you have the slope, you go into point-slope form, where x1, y1 is the point, and even though in algebra we used m as the slope, f prime of a is the slope, m. So I don't want to confuse you guys. It's no different than when you were in algebra class where you had a point, you had a slope, and you wrote the linear equation in point-slope form to convert the tangent line into y equals mx plus b. Find the point, find the slope, convert to point-slope form, convert to y equals mx plus b slope-intercept form. Okay? And and that was a loud round of applause at the age of 21 to a bunch of 18-year-olds. Like, I had just graduated high school 3 years prior, and there I was. That's always going to be a dear memory of mine. So, for instance, let's go back to that y equals x squared. Let me put that down. So the directions say, write the equation of the tangent line. If the graph is f of x equals x squared, standard parabola, I want to find the equation of the tangent line at x equals 3. So the first thing I want to do is calculate where is x equals 3. So I'm going to calculate f of 3. Remember that the graph is x squared. So where's my black and red pen? There you go. So I want to calculate f of 3. Well, x equals 3, 3 squared f of 3 is 9. So what that means is that the point is 3 comma 9. The second thing I want to do is figure out the slope. Well, we don't live in algebra world, we live in calculus world. So we need to figure out what f prime of x is. So the point is 3 comma 9, f prime of x. So if f of x is x squared, that means f prime of x is 2x. And now we want to figure out the slope at x equals 3. So 2 times 3. So f prime of 3 is 2 times 3. That means that the slope at x equals 3 is 6. So that is our x1, y1, and our m is 6. Now we go into point slope form. Sorry about that. Point slope form, and we're later going to convert this into slope intercept form. Y minus y1 equals mx minus x1. So x1, y1, 3 comma 9. So y minus 9 is equal to m equals 6, x minus 3. Are there any double negatives I need to worry about? No. So I'm going to distribute the 6. I get y minus 9 is equal to 6 times x, which is 6x, 6 times negative 3, which is negative 18. And now I'm going to get y isolated. Y minus 9 is equal to 6x minus 18, where I add 9 to both sides. And therefore, I get y isolated. 6x minus 18, I'm going to add 9 on both sides. So 6x minus 9 is the equation of my tangent line. And just to see it in action, so y equals x squared is a parabola. X equals 3 is the point that I care about. Where is the tangent line at x equals 3? So I'm going to pull up Desmos. So x squared is the blue graph, and y equals 6x minus 9, even though it's kind of blurred together. I'm going to touch x equals 3, 9 in the direction of where it's going. So what that tells me is that in the graph y equals x squared, take off the tangent line, it has a negative slope, stops, and has a positive slope, but in particular, this point right here, 3 comma 9, there we go, has a slope of 6. And it's going to touch it right there in the direction of where it's going at the time. That's my tangent line, y equals 6x minus 9. Okay. I'm going to do the same thing with y equals 3x squared plus 5x plus 1. And for a quartic function, an fourth degree polynomial, we're going to figure out their tangent lines. So without further ado, let me put this on the side and I'll deal with you later. Okay, good. All right. F of x is equal to 3x squared plus 5x plus 1. Find the equation of the tangent line at x equals 1, just to make things easier. So without further ado, let's go back to algebra. We need to figure out what the point is. So we need to figure out the point at x equals 1. So let's do f of 1. So f of 1 is 3 times 1 squared plus 5 times 1 plus 1. Well, nothing too exciting about this. 1 squared is 1, 3 times 1 is 3, 5 times 1 is 5, and then plus 1. So 3 plus 5 plus 1, that's 8, plus 1 is 9. Therefore, my point at x equals 1 is 1 comma 9. So then after I figure out what the point is, let's figure out what the slope is. So we need to figure out what f prime of x is. The derivative of f with respect to x, the derivative of 3x squared is 6x. The derivative of positive 5x is positive 5. And the derivative of 1 is 0. So now that we figure out the slope anywhere, let's figure out what the slope at x equals 1 is. So f prime of 1 is 6 times 1 plus 5. 6 times 1 is 6, plus 5 is 11. So the slope is m equals 11. X equals 1 is my x1. Y equals 9 is my y1. So I've got a point, I've got a slope. Let's go into point slope form. Y minus y1 equals mx minus x1. So without further ado, here's the formula. Let's plug them in. Y1 is 9, so I've got y minus 9 is equal to the slope m, 11, x minus x1, which is 1. So now, do I have any double negatives I need to worry about? No. So I'm going to distribute the 11. Y minus 9 is equal to 11x. 11 times negative 1 is negative 11. And now I'm going to isolate y. Y minus 9 is equal to positive 11x minus 11. So if I add 9 to both sides of the equation, cancels out, and my tangent line becomes y equals 11x, negative 11 plus 9. That is negative 2. So that is the equation of my tangent line. In other words, this quadratic has a tangent line of y equals 11x minus 2. Let me set it up on Desmos before I show you. At x equals 1. Just delete that. So now I'm going to show you on Desmos everything all together. So if I have the graph y equals 3x squared plus 5x plus 1, so it is a parabola, different shape than, different stretch factor for y equals x squared. And I put the equation y equals 11x minus 2. Remember that it touches the graph at 1 comma 9 in the direction of where it's going. So the graph meets, the tangent line meets the graph at x equals 1, and the slope is 11 at that particular point. And that is just a thing of beauty. Let me zoom out. Okay. One last problem. We're going to calculate the equation of the tangent line for this graph. Y equals x to the 4th minus x cubed minus 2x squared plus 1. It's funky looking, but not too funky looking. Let's figure out the equation of the tangent line at x equals negative 1. So, same old, same old. How do I figure out the equation of the tangent line? I need a point, I need a slope. I go point slope to slope int. Doesn't get any simpler than that. So I need to figure out f of negative 1. Remember, parentheses are your best friend. So I'm going to plug in x equals negative 1. Whenever I plug in for a particular value of x, remember parentheses, Negative 1 quantity to the fourth power, which tells me that there's going to be an even number of negatives, and negative 1 quantity to the fourth power is positive 1. Negative 1 quantity to the third power tells me that there's going to be an odd number of negatives, so that's going to be negative 1. Negative 1 quantity squared tells me there's going to be an even number of negatives, so that's going to be positive 1. And now I'm going to put everything, every coefficient I see. So this is going to be, well, positive 1. There's a minus in front, so this gets parentheses. The positive 1 gets multiplied by negative 2, and that gets added by positive 1. So I'm going to put everything simpler. That's 1 plus 1. Negative 2 times 1 is negative 2. And then I'm going to add 1. 1 plus 1 is 2. 2 minus 2 is 0. 0 plus 1 is 1. Well, that was exciting. So that means that our point is negative 1 comma 1. So that's going to be our x1, y1. Okay, now I need to figure out what the slope is. So now I need to figure out what f prime of x is. Okay, all right. The derivative of x to the fourth minus x cubed minus 2x squared plus 1. The derivative of x to the fourth with respect to x is going to be 4x cubed. The derivative of negative x cubed, that would be negative 3x squared. The derivative of negative 2x squared would be negative 4x. And the derivative of positive 1 is 0, so that's gone. Now I'm going to plug in x equals negative 1 because I care about the slope at x equals negative 1. So without further ado, let's plug in x equals negative 1. So 4 times negative 1 quantity cubed. So let's take this. Negative 1 quantity cubed, that's an odd number of negatives, so that's going to be negative 1 yet again. I'm going to pull out the negative 3 over here. Negative 1 quantity squared, that's an even number of negatives, so that is positive 1. And then, oh, I forgot to put the negative 1 over here. I was wondering, I was like, did I draw a blank? And I was like, yeah, oh, I did draw a blank, as in I didn't put a number in there. Negative 4 times negative 1, well, that's going to be a positive 4. So now I'm just going to simplify this part over here. 4 times negative 1 is negative 4. Negative 3 times 1 is negative 3. And then we're going to add 4. Negative 4 minus 3 is negative 7. Negative 7 plus 4 is negative 3. So what that means is the slope at x equals negative 1 is negative 3. So we've got a point, we've got a slope. Let's go point-slope form. Okay, so now we've got y minus y1 equals mx minus x1. Remember that y1 is 1, m is negative 3, and x1 is negative 1. Are there any double negatives? Yeah, that x minus negative 1, I'm not a fan of it, so that's going to be y minus 1 is equal to negative 3 x plus 1. Now we're in business. So I'm going to distribute the negative 3. And that leaves me with y minus 1 is equal to negative 3x. Negative 3 times positive 1 is negative 3. And now to isolate the y, I'm going to add 1 to both sides of the equation. So now I've got y equals negative 3x Negative 3 plus 1 is negative 2. So that is the equation of my tangent line. So in the direction, for the curve, y equals x to the fourth minus x cubed minus 2x squared plus 1, at the point x equals negative 1, the slope is negative 3, and y equals negative 3x minus 2 is going to touch the curve at x equals negative 1 with a slope of negative 3. Right, negative 3x minus 2. Yep. So let's look at this curve. We're going to look at x equals negative 1, and let's see if it touches that curve. Oh, would you look? That is poetry. That is poetry. I'm proud of myself. That is a tangent line. Okay. Well, we're going to do more examples of tangent lines next week. Have a great day. But we're going to incorporate a variety of rules. So there might be some chain rule in there. There may be a product rule, and so on and so forth. Don't forget about the derivative rules.